So how do you use solubility to calculate solute mass or solution volume? So essentially, solubility is giving you, well, the units are grams per liter. Solubility is expressing the maximum amount of solute you can dissolve per liter in a saturated solution, okay? So the units of grams per liter is an alternate concentration unit, okay? So remember, concentration is the ratio of mass to volume. So grams would be our unit of mass, and volume would be our unit of, liters would be our unit of volume. So we can see that what we have there, our solubility units, is expressing the concentration in grams per liter of a saturated solution. So in this case, we're asked for the greatest mass of our compound, so we can just rearrange our equation in this case, that mass is going to be our concentration times volume. And if you're not sure, dimensional analysis is your friend. So the concentration was 43.7 grams per liter, and we are going to multiply by a volume. And in this case, the volume was given to us in liters, so that makes it nice and easy on the units. So liters is going to cancel out and it's going to give us a mass in grams. So remember, this is for a saturated solution, so that would be defined as the maximum mass of solute that you could dissolve it per liter of solution. So that would come out to 393.3 grams. So let's see, two significant figures. That'd be 3.9 times 10 to the power of 2 grams. Fine. So I think there's probably going to be more difficult versions of that question, which are going to be a bit trickier with dimensional analysis, etc. So this one, we would have to work backwards from the mass. So we're going to work to the volume from the solubility. So again, you're going to check your dimensional analysis. If you're not sure, we're going to rearrange and solve for volume. So multiply both sides of the equation by volume. You're going to get that we have mass over concentration will give us volume. And again, if you're not sure, dimensional analysis is going to let you know that you're doing the right thing. So in this case, our mass was 43 grams, and we're going to divide that by the concentration, which is in grams per liter, so 35.4 grams per liter. So the grams divided by grams is going to cancel out, and 1 over liters is just going to be liters. Was it just, yeah, those are the numbers. So 43 divided by 35.4 should give me the right answer. So 1.21468, blah, 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 whatever. So three significant digits would be 1.21 liters would be the volume of that saturated solution. So what other kind of possibilities can we have for this? That seems... here we go. I knew it was coming eventually, so, if we need a little bit more testing, we're going to have something like this, milligrams. So in that case, you would have to do a unit conversion. So you know that 1 milligram is 10 to the power of minus 3 grams. Okay, I'm not going to do this exhaustively, but I wanted to do one where the units were not quite so straightforward. So we have our solubility, and again, we have to calculate the volume. So volume is going to be mass over concentration, but of course our units are not going to simplify quite as easily because we have an incompatibility in our mass units, because we have our mass in milligrams, so 480 milligrams we're going to have to convert to grams. So milligrams into grams, we can just take that equivalency and turn it into a unit conversion. So 10 to the power of minus 3 grams is 1 milligram. So we're just going to make sure that's on there. And of course, we were dividing through by the solubility, which is 80.4 grams per liter. So let's just make sure our units all look compatible. I think we're good. So again, before we do anything, we can just check our units. So milligrams is going to cancel, grams is going to cancel, and our volume is 1 over liters, which comes out in liters. Of course, you could have been asked for milliliters or something like that, in which case you could then convert liters into milliliters, for example. So 480 divided by 80.4, whatever that turns out to be, would be 0.00597. So I would assume I've got the right number of zeros, right? There's more. So that would be in terms of standard notation. Let's see, 3 significant digits. Sorry, I should have included more in that case. Being lazy. So 5.97 times 10 to the power of minus. Where's my minus sign gone? 3 liters. And, if you were asked for that in milliliters, you could do that as well. Okay, so I'm pretty sure this question's asking for it in liters, but if you were asked for milliliters, 1 milliliter is 10 to the minus 3 liters. So you could just go ahead and stick your unit conversion on there, like so, and then you would end up with 5.97 milliliters. I'm pretty sure ALEKS wants it in liters. I'm gonna have to check now to satisfy my own curiosity, aren't I? And of course, I was correct in my assumption that it did want it in milliliters. I'm looking from the instructor side of things, so I can't see if there's a prompt saying, "Hey, these are the units," right? So, yeah, that seems good to me. Okay, so just watch out if you do need to convert those units, which we did.